Hi, Omid. Thank you for inviting me. Let's start. So, there's Professor Don Ariely. Everybody knows him. He said some smart sentence. Big data is like a teenage sex. Everyone talks about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it, so everyone claims they're doing it. My name is Alex. I'm from Maccabi Health Services. I claim we do it also. So, let's start with a joke. There was a guy looking for his keys, for his car keys, under the street light. A police officer asked him what he's doing and if he needs some help. No, my keys are over there. The light here is better. So, the light we are talking about is the data itself. And let's start. So again, my name is Alex. I'm the Chief Security Architect in Maccabi Healthcare Services. I'm also the Data Protection Officer. I serve under the Chief Information Security Officer. I practice privacy protection, and I'm an enthusiast about healthcare technology. And we are going to talk about big data aspects in healthcare specifically. What is it? What are the opportunities? And what are the challenges we have? First of all, we need to understand that big data is not only in healthcare, it's everywhere. Everybody has a cell phone. Who doesn't have a cell phone? We have a guy in the office who uses N95 because he doesn't believe in smartphones. But so everything you do, big data is everything you do on the smartphone. Every street you go is data, and this data is being collected somewhere, practically Google. And we will skip this exercise because I think you guys understand the point, and we will continue. So, just in several words, what the hell is big data? And it's not big, the data itself. It's just a collection. And why is the healthcare is so unique? And I will take Maccabi for an example here. We have over 2 million registered patients, over 2 million insurers. And we collect the data. We started digitizing the data in 1998. We took all the paper files and we digitized them. Not like the other healthcare provider we don't talk about, Clalit. They started to digitize the data but didn't digitize back. So we have some advantage over them. So research studies, patient portals, government agency, payer records, smartphones, everything from your wearables, search engine data, public records and EHRs and EMRs and generic databases, we collect everything. You go to the doctor, you say you have a stomach ache, we collect it. But we also protect it. I will talk about it soon. But we collect it for a reason, because we want to give better service to people. We want to promote health. We want to find cure for diseases, and we want to sell the products. We want to make money, also, because we need to live for something. Several use cases for big data in health. I just threw some little examples here. We have Maccabi's מיזם טיפה למחקר. Who's in Maccabi here? Raise your hand. Who gave a blood test recently? Raise your hand. Who was suggested to donate his drop of blood to science? Nobody? You? And did you sign? Why not? Go and do it again.
I was lazy.
Yeah.
By the way, they didn't notification as me to donate the blood.
No. Again, First of all, please, questions later, but for your question, they didn't notify you, so they didn't take your blood. In central areas in Israel, we have stewards that come to the patients in the blood examination rooms and suggest them to donate 1 drop of their blood. It's not 1 drop, it's 5 milliliters. You don't have to give more blood than you give to the test. We just take some of the blood you already gave and we put it in a biobank, like the biobank in UK. Our biobank is an exact model of the UK biobank. Another example is AI1 solutions. You know, the average age of radiologists is about 58. They're all going to be dead soon, and no one would be able to read your x-rays of your lungs or of something. So what do we do? Sorry. So what do? We teach an AI model. We give an AI model and a lot of x-rays. This is a startup. It's not it doesn't have any relation to Maccabi, but Maccabi is participating in it. We are giving them images, anonymized images with no patient records, just the images and the diagnosis. Thank you. Who said it? Cool. We give the image and the diagnosis, and we train the model. We train the AI model to diagnose the x-rays and other image, mammography, bone health, and triage, and blah, blah, blah. So I will emphasize on 2 of the examples today. One is K. Who knows what is K Health? Who used K Health? Who found it good? So K Health uses information extraction from Maccabi. K is, I can't say it's a mutual project because K is a startup that just Maccabi decided to join it because Maccabi owns the data. This application is based on those 2 million patients we have on their data, and it's learning. Now, there are a lot of applications like K, but there's small difference. Let's say ADA. There's an application called ADA Health. It uses documentation, it uses common knowledge, it uses medical books to give you suggestions, to give you treatment, but K uses real life cases. So if you open the application and say you have a headache and your nose is green, so it will find those patients who had a headache with a green nose and give you the treatment, the suggestion for treatment they received. So just a 30 seconds preview on what is it, K. So this is the app. Yes, we transfer about 150 terabytes of data to K and the delta of this data. But of course, we anonymize it, we filter it, and we don't disclose any of our patient information. The application works, as I said, with information extraction. It extracts unstructured data and structured data. text. It's in unstructured data. I mean, it's taking text that the doctor writes. Then it calculates the context, the feature selection, and finds patients, similar patients, and then bring it to you in the app. You all are invited to try. So, and this is the structure of the radiology solution using big data application. So as I said, we take the doctor notes, we take the images, the HL7 data, the JSON files, XML files, the laboratory data that was associated with this patient, and after analyzing it, you can have a pretty 99% diagnosis. This is what this company can do, and it works. And so what can we do? What can we do with this data, with big data in health? So we create risk scores for patients, for health issues, based on lab testing, as you see. We take biometric data, we take claims data, patient-generated health data. Everything we take into consideration, and then we can determine if you're at risk. We can recommend treatment, we can recommend you to change your lifestyle, we can recommend you everything. We can tell you if your situation is good or bad, if it's deteriorating, and we can help you. We can save lives. We can prevent suicide because we can see signs of depression. We can early identify depression. So, and developing precision medicine and new therapies. I will share, of course, the slides if you want. So we have a lot of benefits. Everybody's talking about the benefits of big data in healthcare and machine learning in healthcare. There are a lot of benefits. Personalized medicine, cost reduction to health providers. Now, if the healthcare providers reduce cost, the cost also will be reduced to the patients. Who's in Maccabi? We said we have 5. So your monthly bill will be reducted in 1 shekel next month. Yeah, really. So we can give care in real time, increase transparency, improve patient outcomes, and more research and development of new drugs and new care for illnesses. But this is actually well-known benefits. Sometimes healthcare providers, hospitals, health institutions, and startups don't think about the challenges and risks. And they just go forward and forward, but don't stop and think about the risks. So we have one challenge that is common to every big data application we can think about, that there's not enough data. Because people like Omid, who didn't give his drop of blood. But yeah, people still afraid to share their data. And we have laws, we have GDPR, we have Israeli privacy laws, we have California privacy laws, we have HIPAA, we need to work in those boundaries, and we cannot use the data as we want, which is good, but also bad, because we need a lot of data in order to do good things. So let's take an example from the UK Biobank. The UK Biobank started at 2012. And they had a goal of 500,000 samples. After a year, they had only 5,000 people. They reached the goal eventually, but after a year, they had only 5,000 people. And it's UK, it's not Israel, so And they wanted to check the relation between high blood pressure and coronary heart disease, heart attacks. And you see, how do I do this? Yeah. If we take a sample from 5,000 people, it's really difficult to see the correlation between age and systolic blood pressure. But after a year or so, they had 50,000 people. So the correlation is more obvious here between the age and the systolic blood pressure. And finally, I think they reached their goal at 2016. They had their 500,000. Today they have about 3 million samples, if I'm not wrong, but they reached their goal of 500,000 people. And here you can really see what is the relation between age and high blood pressure and coronary heart diseases. So imagine if I would continue this graph with million, 2 million, 5 million, I can reach a higher accuracy rate of this analysis. And this is only one relation that I'm checking. I can do a lot of researches based on this data, so it's very, very important. It serves everybody. It's like donating your data, your anonymized data today is like donating your blood. So, but there are also security and privacy risks that are important, and a lot of startups and healthcare providers, as I said, pay attention, but not enough. Especially startup companies that want to scale fast, they want to go to market fast, and not because they don't want to, because they don't have the knowledge and they don't know who to ask. So this is just a basic infographic about how to secure your big data environment, your containers, if you store it in the cloud, your databases. So of course, you have file level encryption, which is very difficult to do because you need to access the data on the fly. So nobody does it. But one thing that is very important to do is privileged user access control, which it's important to do. It's easy to do. Nobody does it. I see about a startup a week that comes to Maccabi Research Center to present their product or to use the data. Startups, if you have a startup, you can come to Maccabi Research Center and buy data for your product, for your models, for your calculations. We give you a work environment, a virtual work environment. You can work and develop models. But when we look inside of the software they provide, the applications they develop, they don't use privileged user access control, meaning everybody can access everything. And I'm talking about the employees of the startup itself. And of course, today it's very important to integrate it to SIEM systems. SIEM is security monitoring systems that living people are monitoring the activity on the network, on the databases, on the containers, and of course indicate if something goes wrong. So in a few words, I'm talking about big data, but big data for me is big data. It's a container of data which we can apply machine learning, analytics, on-premise data movement, and real-time data movement on it. And the big data is our source. We use several sources in Maccabi, and we purge it into one data lake. So another thing I want to emphasize about is cluster analysis and the risk about it. So one of the application in big data is to find groups and objects that are similar to each other. In order to research maybe some kind of a disease that can affect a group, or some kind of a gene that is only from Europe, from those who are born in Europe. And this is very, very risky analysis, because we are, let's go to the other side. We have the risk of discrimination. Now let's say who is from Europe, who was born in Europe, whose parents are from Europe. So let's say I found a disease, a gene that is only affects those who were born in Europe. I can discriminate you. I can say that you are not able to come to Israel or to the United States or to any other country. So this is why data anonymization is very, very, very important to practice once you touch healthcare data. And of course, the risk of bias. You must be, the researcher cannot know the race, the names, the origin of those he's researching, because look what can happen. Oh, we can't see it here, but this is a white dude, okay? His name is Vernon. He had 2 armed robberies and 1 attempt armed robbery, and 1 grand theft. But we have here is an Afro-American woman with 4 juvenile misdemeanors and no subsequent offenses. You put those offenses and the photos into some kind of AI model, some kind of machine learning model, and the outcome is that this dude, Vernon, has a low risk. He can go back to society. But Brisha is at high risk. Why? Because the one who coded this software, the one who developed this model, he was biased. Because maybe he was racist, maybe he doesn't like black people, I don't know. But this is the outcome, because it doesn't make any sense. Because if I eliminate those photos, so Vernon should go to jail, and Brisha should go home, because she did something not so bad. So I want to go back to this slide. You see the segregation of roles, the segregation of duties. If you segregate the roles between the developers and the data analysts and the algorithm guys, you probably won't be at risk of bias, because the programmer, the developer, would not have access to the data, to the models. And the data analyst will not have access to the code. And then you can all merge it together and have your software. And then you would have it, the low risk here, the high risk here, and everything will be okay. And this stuff happens. It happens in software, it happens in computers, it happens in real life. So, how do we do it? First of all, we all know the word anonymization. In Israel, the Ministry of Health stated another word, hatmama. There's no such word. I hate this word, but this is the word we use because Ministry of Health chose this word. But I will use anonymization today. So we have anonymization, we have quasi-identifiers, and some of the mistakes I saw is you eliminate the names and social ID numbers and birth dates, but databases are being left with address, region, and who lives here in a city that nobody knows its name except Petah Tikva? No, Harish. So let's say QOERD has, I don't know, has 3 hands. He lives in Harish. Well, it's no problem to find this QOERD because probably there's only one man with 3 hands living in Harish. So we must eliminate also the address and the birth date and the region. We can leave it on south, center, east, but no, not going deep inside. So quasi-identifiers are those identifiers that can link the anonymized identity to the real identity of the person, and there are a lot of them. Hair color, eye color, height, I don't know. When you anonymize tables, it's pretty easy because you have tables. But in health records, the doctor writes in free text. How much time I left? Just
15 minutes.
15 minutes. He writes free text, and in the free text he can describe whatever he wants. And this is the real challenge. But this K application I showed you, the smart dudes there, they somehow managed to develop a script that extracts every personal information from a free text and actually works. So it's pretty cool. Bless you. So, in conclusion, I even ended earlier. Infrastructure security, this is the basis. We need to make sure our infrastructure is secure in secure location. Our data centers are secured. Maybe we store the data in the cloud. So choose a good one. This is the most important to me. And this one, where is it? The integrity and reactive security. We must preserve the privacy of the data. Use cryptographic technologies to enforce data-centric security. Access control, as I said. Store it in a secure data storage. And of course, nothing would be complete without an audit. You must audit your big data solutions, your infrastructure, and of course, keep the integrity of the data. So donate your data. Make sure it's anonymized. Make sure it's safe, but don't keep it to yourself. It can help you. It can help the society. It can help everybody. The 10 simple rules for responsible big data research. I will read them. Acknowledge that data are people and can do harm. Data can do harm. Recognize that privacy is more than a binary value. Guard against the re-identification of your data. Practice ethical data sharing. Consider the strengths and limitations of your data. Big does not automatically mean better. Debate the tough ethical choices and develop a code of conduct to your organization. Design your systems for auditability. Don't close them and make them like Iran, the reactor in Iran. Make them auditable. Engage the data with more data. Share your data with other databases. Connect databases. Connect make a connection between companies. And of course, you must know when to break every one of those 10 rules. Thank you.
Questions?
Yep. Please. What's your name? Nahum.
Yeah. So Maccabi has all this huge data.
Yep.
Suppose that I'm an insurance company in Israel or abroad that wants to do some statistical analysis on the data, and I want to see lots of cases. And so I approach Maccabi. Maccabi will tell me I'm an HMO. I'm governed by the Israeli legal system, so I cannot do these things. But Maccabi has created an interface, Maccabi Tech, that is conveniently able to access the data of Maccabi on one hand, and on the other hand, to anonymize it and sell it to the insurance company on the other hand.
Well, it's a good question.
No, it's not a question.
Okay.
Now, the question is, what authorizes, in terms of data protection and privacy, the transfer of data from within Maccabi to the interface to Maccabi Tech to be sold after anonymization to commercial clients?
Okay. So, thanks.
Alex, just repeat the questions for the video.
I wanted to, from what I understand, for Maccabi Tech,
L-
the interface
let's-
is without specification identification.
Of course. So, I will answer the question. So, Nahum.
Yeah.
Nahum asks, what is the legal grounds for sharing this data? Well, actually, it's pity that I didn't put the slide here, but we actually have legal grounds. Every health, we don't need Maccabi Research Center to share the data. We actually have, there's a, it's not a law, it's a takana for sharing anonymized שימוש משני במידע בריאות. And so legal grounds, we have legal grounds. We don't do anything illegal. Maccabi Tech, we are not able to ask money, yes. Because Maccabi is not able to ask money because it's a government organization.
But Maccabi Tech does this.
Of course, we don't do anything for free. Do you?
No, the issue is the money stays outside Maccabi and outside the Kupat Cholim.
No, it's not. No, it's not. The money goes in. The money goes in investments. The money goes, Maccabi Tech invests in Maccabi. The entire Maccabi Tech is being funded by Maurice Kahn and Sami Segol. The data is cheap. Maccabi is not making a lot of money from this data. Don't think we are doing a lot of money. But yes, so we have legal grounds. Of course, no insurance company yet had approached Maccabi to buy this data, and I don't think Maccabi will sell from many reasons. But even if we do, what's your name?
Me?
Yeah.
Ovadia.
Ovadia. As Ovadia said, the data is anonymized. And of course, we would not want the insurance company to find out anything about you and then raise up your premium, because you can sue us and you would win. So that's it.
One more question.
Yes.
When I sign into any insurance company, that in any case I have אני אעשה את הניבו, because I don't find the English, את החיסיון הרפואי שלי, שאני חותם על החיסיון, הם עושים את החיתוך איתכם, זאת אומרת עם מכבי, זאת אומרת יש אפשרות שהם יכולים לקבל את הדאטה?
No. So the question was, if I voluntarily dismiss the rights for my privacy in health, in my health records. So no, nobody goes, when you sign this authorization, the Vitur Sodiyut Refuit, to any company or any organization that you sign a contract with, nobody goes and actually looks at your medical records. They keep this authorization when they have some kind of dispute with you. If you file some kind of, if you file a claim, and they think you're lying, they will go and ask your medical data, and then they have the authority to receive it. But they will receive only your data. They will not receive any statistical data. They will not receive any other data. They will receive your medical records because you signed up. You signed it up. So, but actually, no one uses it. Only in cases of dispute. Automatically, no one takes your data. Yeah. What's your name, please?
Shira.
Shira.
I work at investing.
You work in?
Investing here.
Ah, okay.
As a data analyst. So from a data analyst perspective, for the analytics you have from Maccabi, right? How exactly, see, I have Maccabi, I have the app. The reason why I switched to Maccabi was for the app, for the digital side of things. I often wonder in my own use, like how are the analytics used to make my experience better? Meaning, let's say I use the app and I generally use one specific part of the app. Is that information analyzed to then show me that part of the app more, or to improve that part of the app for me?
Well, good question. Repeat? Yeah. So Shira asks how we use the statistical data of the usage in the app. We want to. It's a new app. It was released 3 days ago. I think 5 days ago.
New version.
Yeah, it's a new version. It's actually a new app. It's not even a version. It's everything new. The old one is in the trash. So, but we do collect statistical and we collect usage logs for enhancements, for bugs, but and maybe we will do something with it. But no, we don't do personalization today. Maybe we will, but it's not my domain. So, but if you want, we can talk about it later. Yep.
How do conclusions from, let's say, all kind of analysis?
Again.
How do your conclusions come back to the patient?
How do my conclusion? Okay. Try to go back to the slide. It's not actually my conclusions. It's the healthcare community conclusions.
Yeah.
But let's take this example again from this Biobank UK. So they found, maybe they knew it before, but now they know it better. I don't know. But they found that there's a close relation between high blood pressure and coronary heart disease. So, in order not to die, you need to lower your blood pressure. Now, this is one conclusion you can make, because I don't know if they knew it before this research. Maybe they didn't. Maybe they thought high blood pressure is fun, but now they know it can make you dead. So this is one conclusion. Research, development, nothing is coming. I cannot say that you have an immediate effect using big data, using research on big data. is immediately affects you or any of us here. It does affect the general public. It can affect you tomorrow if you're pregnant and there's a new research that most of the pregnant women that ate cucumbers had healthier babies. I don't know. But this is the kind of benefits you can have.
It is, but is it like happening now?
Of course.
There are institutions, would you call the patient and tell them?
Oh, now I see. First of all, yes. If we do genetic research, if we take your blood, for example, and during the analysis of the blood, we know whose blood is it. We have identifiers. We can go back. We have the real identifier of the blood in safes, in secure location. We can always track back to the origin who gave this blood. So during the analysis of the genomic sequence, we find some kind of anomaly. We must contact you and tell you about it. It's by law. It's ethical. First of all, it's by law. Second, it's ethical. It's like you donate blood, and the samples they find HIV in the sample. They call you. The same thing. Who? Yeah.
Michael,
Hi, Michael.
do you use any external data to confirm identity, to improve?
God forbid. God forbid. No, we don't use we use external medical data, yes. Sometimes we have some kind of cooperations with Clalit, with Meuchedet, with health organizations from abroad regarding medical data, genetic information. No cooperations with identifying data. And so this is why it's important to say the state of Israel invested about 1.2 billion shekels in building something like Maccabi Tech for general public. And they asked us to put Maccabi's data inside. We refused because one of the benefits, it's called, I don't remember the name of how they call their projects, but one of the benefits that I can correlate with a lot of databases, with Mirsham Ochlusin and several offices. We don't want it because it's a risk. So we didn't do it. But so the answer is no. Yeah, just 1 second. Yes.
Regarding bias, are there any tools we can use to detect data bias? Like, I guess Maccabi has a certain demographics which is different from, Clalit. So the data samples you would have, you could probably see that there.
Yes. So I will answer. Yeah. So what's your name again? Omer. So Omer asked, can I detect bias after I analyze the data, after I processed it? Maybe. I don't know of any kind of solutions that can do it.
If you don't anonymize the data,
If I don't anonymize the data,
it's possible.
I'm not processing any unanonymized data for research purposes. I mean, we process data, we process unanonymized data for medical aspects like in patient care, but we don't process any unanonymized data for research. But maybe there are solutions that can identify patterns which can indicate bias. I'm not aware of those kind of solutions. Yes.
IBM has actually done that in Washington.
Yeah.
Where they have a specific solution for detecting bias.
Really?
Yeah. There's a fellow that does it, I think out of the Haifa Research Center.
Yeah.
If anybody's interested, I can give you his name.
I will. It's really interesting, yes. But of course, the precautions you must take before in segregation of duties and in anonymizing the data should, I can't say eliminate the bias, but reduce it to minimum as possible. Anyone else? Yes.
Are you really sure that Maccabi Tech, before they anonymize the data, don't use the ID number to cross with external databases and then anonymize it?
Yes, I'm sure because I make sure of it. And I'm liable. Maccabi Tech itself knows the identity of the person because they are all employees of Maccabi. And even doctors inside Maccabi who decide, or not even Maccabi, in any of the HMOs who decides to do research, they receive anonymized data. Of course, in order not to look them up in the health records afterwards, but the ones who work on the data, the ones who prepare the data, yes, there are some who knows they receive the blank databases, they need to anonymize it so they know the origin of the data, but nobody cross-referencing. I can say 99.9%, and this 0.1% that is doing it, I really can't know. But the benefit in this specific situation, the benefit is greater from the risk.
If I may?
Yes.
Generally speaking, privacy issues, if you implement protocols within the company, like you said, access, you limit specific people access to specific data. So you minimize the risk to a small percentage of group of employees that have access to everything, but the rest have limited access. So either they get their raw data, but they don't get the anonymized data, or they have access to the anonymized data, but they don't have access to the raw data, or some sort of permutation. For example, they only have access to aggregated statistical data, but not the raw data. So there's a lot of safeguards you can do on top of the data in terms of security, instead of operation. There's many ways to restrict access and security, let alone encryption and all that. Okay? Processes de facto.
There is a distinction between technical security and policy.
Of course.
I looked in Maccabi Tech's website about a year ago, and at least at that time, the practices that I mentioned of crossing using the ID number and selling to insurance company were practically advertised, like by Maccabi Tech. So
I'm not sure what is it. We can talk about it later. You can show me. I would be glad to see it. I don't know about it.
Any questions before we switch to the next lecture?
You talk about all the testing or the health checking data. Do you
Again, about the health.
all the testing, blood testing?
Okay, yeah.
Do you use the treatment data? Which treatment to what
Of course.
disease?
Of course. When we take a blood sample to a biobank, after we genetically sequence it, before we transfer it to the biobank, we take the real identification of it's not only us, again, it's every biobank in the world. The sample is stored, and the anonymized medical data, it's not stored together, but it's also getting into the biobank's database, because we want to know what kind of, we need medical information, we need data in order to sequence it together. We don't match it, we don't match genetical information with this person's EHR data, because then we can match it, and there's a risk of identification. But we need this medical data in order to derive some kind of insights, yeah.
I'm talking about the effectiveness of a medicine or something like that?
Yes, but this is more of a human trials, it's a drug trial. It's not so much of a data research. There are researches that you have retrospective research when you take a specific list of patients that you know that received some kind of a medication, but this is an internal research. It's non-anonymized research. It's identifiable because you need to know the patients who took this specific drug, and then to see maybe they have some kind of side effects or illnesses, or maybe death, or maybe they're cured. But this is the data research you can do. But if you want to test effectiveness of a drug, you do phase 1, phase 2, phase 3 researches. It's human trial researches.
But are you using, in Israel, are you using international standard coding systems like ICD-9, ICD-10?
Sometimes.
So only sometimes. So when a doctor enters whatever they've done some activity or something.
You mean in the EHR? Yes, we are. Yes,
Is it ICD-10 or
I think it's ICD-9. It's ISO 9001 standard. Yes, of course. Any more questions? Yes.
Back to the question about giving the patient. So you talked about known things, but let's say, for example, here you see a trend.
Yeah.
And now you have a person that is in the trend. You see that it goes up, but it's not yet really up. So it's lower than the limit that Maccabi usually sets.
Yeah.
But there's a trend.
Of course.
Do you go back to the patient?
Of course. No, I don't go back to
Or
the.
to the doctor and tell him notice and warn the patient.
So basically, you're asking, well, I've done this research. It costs me a lot of money. Now, what do I do with this information? No, I don't call every 500,000 people by phone and tell them, listen, you need to reduce your weight. You need to take statins. No. But what I can do, I can have, start health programs. I can start finding those patients. Start a program that a doctor will find the patients that are at risk and recommend them do sports, lower weight, take statins, and lower their blood pressure in order not to die. But it's not something that after the research people sit and call those patients and say, well, listen.
Something that the doctors know right now that this.
Specifically, the doctors don't know anything. The doctors today, this is why a healthcare organization is built not only from doctors, it's a lot of personnel, but a doctor has only 7 minutes per patient today. So he doesn't have time to call every fat or sick or, I don't know, patient and tell them go on a diet. And this is why health organizations all over the world, they rely on research like this, and to develop health programs to promote health, and of course to find those patients who are at risk, and then you can use BI solutions in order to scan your medical data inventory and to find those patients who had bad blood tests or who has some kind of extreme weight gain, and call them, yes, but not the doctor, the nurse. Yeah.
In this kind of database, actually the insurance company, if they bought it from you, they can actually see on each age which disease they can raise their price on each age. What kind of disease they have to be cared, and then to update the price.
Basically, they can. They don't need. They know.
You know what I?
Yep. They don't need to buy this information from anyone. Because first of all, the research is publicly available. They don't need to buy data and make the research by themselves. It's not financially.
Actually, because it's from the blood test.
Yeah, but it's publicly available. It's not something that is kept secret.
I thought it's in inside Maccabi.
Yeah, the data.
The data.
The data. This is the conclusion. This is.
The conclusion you advertise.
Of course, every research, every medical research, there's a code of conduct. It's called good clinical practice. You want to do a research, you must go through a Helsinki committee, you must receive an approval, and you must publish your research to the public. If you don't publish, you don't do the research, because every medical research must be done for the common good. And nobody does those kind of research for itself. It's not financial. It's not. But we do it in order to promote health, in order to find. Let's take for example. I will find that I don't know, eating chips gives you cancer, but I won't tell anyone. It's not okay. I need to tell everybody. Yeah. So we have time for 1, 2. No, that's it. Thank you, everyone.
Comment about the visualization. I understand the choices they made.
Okay.
For the purpose, but just note that it's very misleading.
Why?
The x-axis is cut, the y-axis is logarithmic. It's very problematic from other.
I will call them and tell them. I'm sorry.
No, the maybe is to condense the data. But
Yeah.
Age is much stronger factor here than blood pressure, for example. If
Maybe.
you take into account the logarithmic scale and etc. Okay.
Thank you.